Okay, finally, our last problem in the review. We got a physics class investigating what happens when the ball is given a push up an inclined plane. Now, what I've noticed from some students is that this problem didn't make any sense when they first read it. Go ahead and draw a picture. We know that an inclined plane is essentially just a ramp, and they're starting down at the bottom and with a ball at the bottom, and they're pushing that ball. Now, they're not pushing it hard enough to get all the way to the top and then fall off the back side. They're pushing it enough that it goes up, and then gravity eventually takes over, and it comes back down. So if you forget about the horizontal and think about just how the thing is going up and down, that ball is going to track up and then come right back down. Gravity is going to have its effect. And we talked about in class how anytime that we talk about something falling or being affected by gravity, it's always going to have a parabolic path. So if I was to graph that thing this direction, the ball would start low, it would go up, have its peak, and then come back down, and we're going to have a parabolic curve. So it gives us this equation, y equals negative x squared plus 6x. Well, let's go ahead and plug everything in and get a table out of that thing. Luckily, we got our handy-dandy calculator. If I can get my calculator up instead of my phone. Okay, y equals negative x squared plus 6x. Go to the table. And I want my first first 7 values. 0, 0, 0, 0, 1, 5. Let's see, 8, 9, 8, 5, and 0. Okay, done with that guy. Now, let's go ahead and put these on the graph. Something to keep in mind. Sketch the graph in the grid provided. Make sure you label your axes. What does our x-axis represent? What is it always represented in these problems? Okay, time in seconds. And that's also very nice that it said time in seconds right there. What's y going to be?
Height.
Position, height. I guess either way in this one it could be position or height, but it says, horizontal position or height. But in this case it's talking about position. So we got position. How much do I want each of these lines to be on my x-coordinate? What do I want my scale to be? Ones. So 1, 2, 3, 4, 5. What do I want my verticals to be? Okay, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, and then 1, 2, 3, 4, 20. Okay. Plot our points. 0, 0, 1, 5, 2, 8, 3, 9, 4, 9, 5, 8. Did I get off? 0, 1, 5, 2, 8. It's supposed to be what? 1, 2, 3, 4. Oh, 8, 5, and then 0. Sorry about that. Okay, there's my parabola. Second part, determine a reasonable domain and range for the situation. What do I always use to start writing my domains? Sandwich. Okay, got the X sandwich. Now, what goes on the left?
Zero.
Why 0?
That's smallest x.
Smallest x. What's my biggest x? 6. And what do I start with my range? The Y sandwich. And what's my smallest y?
0.
Biggest y? 9. All right. What are the solutions to the quadratic function? X equals. Where do I find solutions, guys? On the graph. Where on the graph? Thanks for stating the obvious. Yes, it's on the parabola. Come on, guys, where do I find this? We've done this too many times. Where do I find it?
Where they like are
Where what meets? What's they?
on the x-axis.
Oh, across the x-axis, the zeros. Thank you. So, where is that?
6, 0.
0 and 6. What do the solutions mean in this problem? What's their interpretation? What? Starting and ending? Good. We talk about meaning. We have to use words that came from this thing, situation words. Does minimum and maximum have anything to do with the physics class rolling a ball?
The initial push and the back down.
Because when we talked about at the very beginning, that this thing goes up and then back down.
The initial push.
So it's the times when it starts and when it gets back to the beginning. Okay? So, again, please make sure that your sentences make sense. The solutions represent the time that the ball is at the bottom of the inclined plane. And with that, we are finished with our review. Good luck on that test.